In this video, we will be looking at quadratic functions. We're going to start with the properties of a quadratic graph. So we will be looking at a quadratic equation in the form f of x equals ax squared plus bx plus c. In this form, if the a value is greater than 0, meaning it's positive, then the parabola will open up, like this first example here. If a is less than 0, meaning it is negative, the parabola opens down, like this one. One silly way to remember this is that positive numbers make us happy, so we smile. Negative numbers make us sad, so we frown. If that helps you remember that, awesome. If it doesn't, forget I ever said it because it's kind of weird. Anyhow, the vertex is going to be a special point on our graph. It's going to be the lowest point if our parabola opens upward. It's going to be our highest point if our parabola opens downward. Now for this point, xy, that the vertex lies on, the x value is going to be negative b over 2a, referencing the a and b we saw in the formula. To get the y value, we're going to plug in that x value into the equation and see what we get out for y. The axis of symmetry is going to be the vertical line that goes through the vertex. Since it's a vertical line, if we think Vux Hoy, then vertical lines have an undefined slope and their equations are x equals a number. Well, the number that it's going to be equal to is the x value of the vertex, that negative b over 2a. So this x equals negative b over 2a is a really important equation that you're going to want to remember. So we're going to be looking at a graph here. We want to find the vertex, the axis of symmetry, and determine where it is increasing and decreasing. So this is an upward opening parabola, meaning our vertex is going to be this bottom point here. We want the coordinates of that point. The x value is 1 and the y value is negative 3. So our vertex is at 1, negative 3. The axis of symmetry is the vertical line that goes through the vertex. So that vertical line will have an equation x equals 1. And your equation will always be x equals the x value of your vertex every single time. Now we need to figure out where it is increasing and where it is decreasing. So remember, increasing means we're going up and decreasing means we're going down. So it looks like we are going up starting at x equals 1 through infinity. So we'll have 1 to infinity is increasing. And then we'll be decreasing on this first side, which is negative infinity to positive 1. Now remember that increasing and decreasing, we're always going to use parentheses on both sides of the interval because at the value 1, we are not increasing and we are not decreasing. We are just standing at a point. So at that point, we are not increasing or decreasing. This time, we're going to do kind of the same idea, but we're going to be given the function f of x equals negative 3x squared plus 6x plus 1, and we want to see if we can find the vertex and the axis of symmetry this way. That's where that important equation x equals negative b over 2a comes into play, so we're going to have to be using that. So if our function is f of x equals negative 3x squared plus 6x plus 1, then to find the x value of the vertex, we're going to have negative 6 over 2 times negative 3. That's negative 6 divided by negative 6, which is a positive 1. But remember, that's only the x value of the vertex. We need to find the y value because the vertex is a point. So I need to plug in 1 to this equation. So f of 1 is equal to negative 3 times 1 squared plus 6 times 1 plus 1, which is negative 3 times 1 plus 6 plus 1, which is negative 3 plus 6 plus 1, which looks like 4. So we have our x value and our y value. So 1 comma 4 is going to be our vertex. So you have to keep in mind that our vertex is always a point. For the axis of symmetry, we use the same equation that we did for the x value of the vertex. That was x equals 1 is what we got in the end. That is our equation. That's all there is to it. Don't overthink it. Finally, we want to know if the vertex is a maximum or a minimum. What we need to do is we have to figure out whether this parabola opens up or down. The way we tell is by looking at the a value. Our a value is negative, which means our parabola opens downward. So our vertex is going to be that top point there, meaning it will be a maximum. So far we've been looking at these parabolas in standard form. There's another form called vertex form, which can be really helpful sometimes. So this vertex form is f of x equals a times x minus h quantity squared plus k. What's super great about this vertex form is that we can find the vertex so easily. Our vertex is going to be located at h comma k. Notice that there's a negative in front of this h. So in the formula, we're going to have to change the sign on h, but the k is just going to be that number out back. Something else that's really nice about this form is that the value of a is the same in both forms. So the sign of a is still going to tell you whether the parabola opens up or down. So even if in this form, if a is positive, it will open up, and if a is negative, it will open down. So we have a parabola here, and we want to find an equation for it. This is one of those times where vertex form is going to be really super helpful. So for our vertex form, we had f of x, or we could use y, is equal to a times x minus h quantity squared plus k, where h comma k is our vertex. So right now, I can find our vertex that has an x value of 2 and a y value of, well, if negative 2 is here, then negative 1 is going to be there, meaning there's going to be negative 3. So 2, negative 3 is going to be the location of our vertex. So I'm going to go ahead and plug that in. That'll give us y is equal to, I don't know what my a value is yet, x minus the h value, which is the x of the vertex, so that'll be 2, quantity squared, plus the k value is our y value of the vertex, which is a negative 3. So instead of writing a plus negative 3, I'm just going to write it as a minus 3. Now we still need to find that a value. I can tell that it's positive, but that's not enough. I need to find the actual value for it. So what I'm going to do is I'm going to find another point on this graph and plug it in. So I need to find a point where I can really tell what the coordinates are. And it looks like right here, I have pretty good coordinates. That has an x value of 1 and a y value of negative 1. So I'm going to plug that into the equation I have right now. So y, which is negative 1, is equal to a times the x value of this point is 1 minus 2 quantity squared minus 3. That gives us negative 1 is equal to a times 1 minus 2 is a negative 1 quantity squared minus 3. That means negative 1 is equal to negative 1 squared is a positive 1. So I just have a times 1, which is 1a, just a, minus 3. Then I can add the 3 over. I get a is equal to 2. Once I know the a value, I can go back and plug it into my equation. And we will have y is equal to 2 times x minus 2 quantity squared minus 3. That is the equation of this graph. The steps we do to figure this out should remind you of using y equals mx plus b to find the equation of a line. How we have to find the b value and go back and plug it in. We're just finding the a value in this case. We can't just leave the a there. We have to find a value for it, so we have to plug in a point to find the value of it. Next up, we're going to be working with the properties of a parabola. It says to consider the function f of x equals 2x squared plus 8x plus 7. We want to know if the parabola opens up or down. We want to find the vertex the axis of symmetry, the y-intercept, and the x-intercept. And I'm going to graph it while we're at it, just to kind of get in that mode. So does the parabola open up or down? That's an easy question to answer because we only need our a value, which is a positive 2. Since it is positive, we know the parabola opens up. Next up, we want to know the vertex. So to find the vertex, we need to use the equation x equals negative b over 2a. So in this case, we'll have x is equal to negative, my b value is 8, over 2 times my a value, which is 2. So that's going to be a negative 8 over 4, which is a negative 2. So I know the x value of my vertex is negative 2. To find the y value of my vertex, I need to plug that in. So I have 2 times negative 2 squared plus 8 times negative 2 plus 7 equals negative 1. So the y value of my vertex is a negative 1. That means my vertex is located at negative 2, comma negative 1. My axis of symmetry, I use the same formula that I did for the x value of the vertex. So we get x equals negative 2. Then we need the y-intercept. To find the y-intercept, we let x be equal to 0. So we're going to plug that in. If x is equal to 0, then we'll have f of 0 is equal to 2 times 0 squared plus 8 times 0 plus 7, which is just 7. The y-intercept is an actual point, so we need to write it as an ordered pair. X comes first, so we'll have 0, comma 7. Then we need our x-intercept. To find the x-intercept, we need to let y be equal to 0. So if I let my y be 0, which is going to be the f of x, I will have 0 is equal to 2x squared plus 8x plus 7. Looking for greatest common factor, it doesn't look like there's one other than 1. Factoring doesn't look too pretty, so let's go ahead and try using the quadratic formula. The quadratic formula says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to go ahead and start plugging in some values. So we'll have negative 8 plus or minus the square root of 8 squared minus 4 times 2 times 7 all over 2 times 2. So that will be a negative 8 plus or minus the square root of, I'm going to go ahead and type the part under the radical into my calculator. 8 squared minus 4 times 2 times 7 is equal to 8. That's all over my 2 times 2, which is 4. We need to see if we can simplify that square root of 8. Well, 8 is 2 times 4, and 4 is 2 times 2. So I have a pair of 2's and 1 2 left over. So that means I can write the square root of 8 as 2 times the square root of 2. So I'm looking at negative 8 plus or minus 2 times the square root of 2 all over 4. And I need to see if I can reduce that, which I will be able to if I break it up. Looking at negative 8 over 4 plus or minus 2 times the square root of 2 over 4, I can reduce both of these. So I'm going to get a negative 2 plus or minus the square root of 2 over 2. That's going to be my x value. So I can write this as an ordered pair. My first x value is negative 2 plus the square root of 2 over 2, and then comma 0 because the y value is 0. And my second x-intercept will be negative 2 minus the square root of 2 over 2, comma 0. It is perfectly okay to leave our x-intercepts this way. So negative 2 plus square root of 2 over 2 comma 0, and negative 2 minus square root of 2 over 2 comma 0, or we can switch them to decimals. It doesn't matter either way. Finally, we want to see if we can graph this thing. If you ever don't know how to graph something, your best bet is going to be to make a t-chart. So pick some x values, plug them in, see what you get out for y. One thing that's going to really help with parabolas is if you put the x value of your vertex in the middle of your table and then go 2 places above it and 2 places below it. That way the points will most likely fall on the graph. So I'm just going to plug in all these values of x and see what I get out for y. I already know if I plug in x equals negative 2, I get y equals negative 1. So I just need to plug in the rest. So we get 2 times negative 4 squared plus 8 times negative 4 plus 7 is a positive 7. I can do the same thing, whoops. If I do 2 times negative 3 squared plus 8 times negative 3 plus 7 gives me a 1. If I plug in a negative 1, oh, I get positive 1 again. And if I plug in 0, oh, we already know what happens when I plug in 0. If I plug in 0, I get 7 because that was our y-intercept. You may notice that it goes 7, 1, negative 1, positive 1, 7, how that kind of repeats itself. It should, because x equals negative 2 is our axis of symmetry. So it should be symmetric over that line. And what these y values do is they show us that. So if I plug in these values, we get negative 4 comma positive 7, negative 3, positive 1, negative 2, negative 1, negative 1, positive 1, 0, 7. That's enough to give us kind of the shape we're looking for. That's going to be our parabola. So when in doubt, if you ever don't know how to graph something, please, please, please use a t-chart. Plug in some values of x, see what you get out for y, and you'll be able to figure out what's going on. We are going to reference back to that graph a little bit by looking at a few more properties. First off, we want to know what is the domain and what is the range. So when we're thinking domain, we're thinking x values. When we're thinking range, we're thinking y values. So for the domain, that's asking what x values we're going to touch. Well, this opens to the left and to the right, so we're going to be going left and right forever. So that means our domain is going to be all real numbers, which we write in interval notation as negative infinity to positive infinity. For our range, we're looking at the y values that we're going to touch. The lowest we ever go is our vertex, and that has a y value of negative 1. So we're going to go from negative 1 to positive infinity. We always use parentheses on the infinity, but our negative 1 is going to get a square bracket because we have a point that exists that has a y value of negative 1. Kind of in the same ballpark as our range, we're going to look at the maximum and minimum values, but they might become a little bit surprising. So when we're trying to find the maximum and minimum values, we're looking for the y values. Well, this goes up forever. So you might think our maximum value is infinity, but we're going to say that the maximum value does not exist since there's not a single number that we don't go above. So infinity might make sense, but we're going to say that the maximum does not exist because there isn't a single number that we don't go above. The minimum, on the other hand, if we're thinking in terms of y's, the lowest we ever go is this y value of negative 1. We're never going to go below that. So our minimum is going to be negative 1. So there we're just looking for the y values that bring us the highest and the lowest. Now that we've looked at some quadratic functions, we're going to look at some application problems for them. So first up, the average cost to produce X widgets from the widget factory is C of X equals 0.2 X squared minus 30X plus 5,000. We want to find the minimum average cost and the number of widgets that should be built to achieve that minimum. So when I see minimum, I'm thinking vertex because this parabola has a positive A value, meaning it opens up. So if we're finding the minimum, we're finding the vertex. So we're trying to find the minimum average cost and the number of widgets that should be built to achieve that minimum. So I'm going to start by finding the vertex. So we'll have X is equal to negative B over 2A, which will be negative 30 over 2 times 0.2, which is a positive 30 over 0.4, and 30 divided by 0.4 is 75. Well, X is the number of widgets, so we will need to make 75 widgets. But now we want to find the minimum average cost. Average cost is C of X, so I just need to plug in 75 for X. So the cost to make 75 widgets is equal to 0.2 times 75 squared minus 30 times 75 plus 5,000. Plugging that in, we have 0.2 times 75 squared minus 30 times 75 plus 5,000. I'm getting 3,875. So our minimum average cost will be $3,875. That's all there is to that one. So when we're trying to find the minimum, we are looking for the vertex. Sometimes we'll be looking for a maximum, and that would be the case if our parabola were to open downward. This next one has a lot of parts to it, but what it does is it takes a lot of ideas that we've learned about parabolas and puts them together. So a rock is thrown up from the top of a 112-foot high cliff overlooking the ocean at a speed of 96 feet per second. The rock's height above the ocean can be modeled by h of t is equal to a negative 16t squared plus 96t plus 112, where h is the height and t is the time in seconds. We want to know what is the initial height of the rock, when does the rock reach the maximum height, what is the maximum height, when is the height 240 feet, and when will the rock hit the ocean. So there is a ton of stuff going on here. I'm going to start by making a picture because I think that'll really help. So we're on a cliff, and that cliff is 112 feet high. And we are taking a rock, and we're chucking it off the cliff, and it's going to come down, and it's going to hit the ocean. And when the rock hits the ocean, it's going to make a splash. If you don't draw the splash, your diagram's wrong, so make sure you draw the splash. All right, so figuring out what's going on here. First up, we want to find the initial height of the rock. Well, we have to know that initial means starting. So we want to know what was the height when we first started. Well, when we first started, that means time is beginning. So we're going to plug in t equals 0. We want to find the height at that time. So the height at time t equals 0 will be equal to a negative 16 times 0 squared plus 96 times 0 plus 112. That's equal to 112. Hopefully that makes sense because the rock is starting on the 112-foot high cliff. So the rock is starting at 112 feet. Next up, we want to know, when does the rock reach the maximum height? Well, the maximum height is going to occur at the top of that parabola, at the top of a downward opening parabola. If it's a downward opening parabola and we want to find the top, we're thinking vertex. Normally, we start with the equation x equals negative b over 2a. But if you look at the equation for this problem, we don't have any x's. Instead of x, we're using t. Well, that's really convenient because we want to find the time that the rock reaches the maximum height, because it's asking when. So if I go ahead and plug stuff in, we'll have negative 96 over 2 times negative 16, which is negative 96 divided by a negative 32, which is 3. Well, we were measuring time in seconds, according to the problem. The rock reaches the maximum height after 3 seconds. Next up, we want to know, what is the maximum height? So that means we're trying to find a height, and if we're trying to find a height, we need to know a time. Well, we know when the rock reaches the maximum height, that's at 3 seconds. So I just need to find the height at 3 seconds. So I'm going to be taking that 3 and plugging it in for t. So the height after 3 seconds is equal to negative 16 times 3 squared plus 96 times 3 plus 112. Using my handy dandy calculator, we have negative 16 times 3 squared plus 96 times 3 plus 112. 256. So it looks like the maximum height is going to be 256 feet. Next up, we want to know, when is the height 240 feet? Well, we know that the lowest it ever is 112, so it's got to be hitting it while it goes up. We want to know when, so we're looking for a time, and we're plugging in a height of 240 feet. So for this part, I know what height I want to reach. That's 240. That's going to be equal to my negative 16t squared plus 96t plus 112. Now this is a quadratic equation because my t is squared. To solve quadratic equations, I need to have a 0 on one side. So I'm going to start by subtracting 240 from both sides. That's going to give me 0 is equal to a negative 16t squared plus 96t minus 128. I'm going to see if there's a greatest common factor I can factor out of all of these. Since my a value is a negative 16, I'm going to see if everything's divisible by 16 and just really hope. So if I do 96 divided by negative 16, well, that's a negative 6, that's not bad. And then negative 128 divided by a negative 16 is a positive 8. So I can factor out a negative 16 from all this. If I factor out a negative 16, then I have t squared minus 6t plus 8. Well, that even factors. I'm not going to have to use quadratic formula at all. I'll have 0 is equal to negative 16 times. Because my a value is 1, I can set up my parentheses with my variable t in front. I need two numbers that multiply to give me positive 8, but add to give me a negative 6. That's a negative 2 and a negative 4. Once I have it all factored out, then I can use the zero product principle by setting each part equal to 0. So either negative 16 equals 0, which it doesn't, or t minus 2 equals 0, meaning t equals 2, or t minus 4 equals 0, meaning t equals a positive 4. So it looks like I have two answers here. Is it possible for me to have two answers? Does that even make sense? Well, I want you to think back to part C. In part C, we found that our maximum height is 256 feet. In this part of the problem, we want to know when is the height 240 feet, which is lower than 256. So what we're doing is we are finding the time on the way up and on the way back down. That's why we're finding two separate answers. So at 2 seconds and at 4 seconds, we are at that height of 240 feet. So sometimes it is okay to have two answers. You just have to make sure it makes sense. Finally, in part E, we want to know when will the rock hit the ocean? When the rock hits the ocean, that's going to be a height of 0. So I'm going to plug in my height as 0 and see what happens. We'll have 0 equals a negative 16t squared plus 96t plus 112. I'm going to go ahead and start by seeing if there's a greatest common factor I can factor out, because last time that made life a lot easier. We already know I can factor out a negative 16 for my t squared and my t term, so I just needed to know if I can do it with 112. And I can, awesome. So I'm going to have 0 equals negative 16 times t squared minus 6t, and now we have minus 7. And that factors as well. So we'll have 0 equals negative 16 times my two sets of parentheses with t's first. I need a minus 7 and a plus 1. Then I just use my zero product principle. Either negative 16 equals 0, which it doesn't, or t minus 7 equals 0, meaning t equals a positive 7, or t plus 1 equals 0, which means t equals a negative 1. Well, in this world, we don't go back in time, so we can't have a negative time. That leaves us with t equals 7. So the rock will hit the ocean after 7 seconds. Now, as you're practicing these, know that you're not always going to get such nice answers. Sometimes you might have to use the quadratic formula and get those nasty decimal answers, but you can always use these tactics of checking for a greatest common factor and try factoring to see if you do get the nice answers. If you prefer the quadratic formula, use it. I personally prefer factoring, that's why I'm showing it. But if you like the quadratic formula, seriously, go for it. One last problem to look at with quadratic functions. We're going to do a quadratic modeling problem. It says a backyard farmer wants to enclose a rectangular space for a new garden within her backyard that has a stream on one border. She has purchased 80 feet of wire fencing to enclose 3 sides. The stream serves as the 4th side. Find a formula for the area of the garden and determine the dimensions that would maximize the area. Then find the maximum area of the garden. They included a nice picture for us that these two sides we can call x. We're dealing with trying to find the area of this garden. Well, since it's rectangular, we know that area is length times width. So we're using x for the width. I need to figure out what my length is here. The key piece of information is we have 80 feet total. So we know that x plus x, which is 2x, plus the length of the garden has to equal that 80 feet because the stream is bordering the 4th side. So we just need to add up these 3 sides to get 80. So to find the length, I can subtract the 2x over, and I get the length is 80 minus 2x, which should make sense because you're going to use whatever's left over from the 80 feet on this side after you take out x for those 2 sides. So I'm now going to plug in the information I have. The area is equal to the length, which we said is 80 minus 2x, times the width, which we're using x. The problem is I need that x to be multiplied by the whole length, so I'm going to put it in parentheses. If you prefer, you can write it as x times 80 minus 2x. The order doesn't matter as long as they're multiplied together. That way I can distribute through the parentheses, and we'll have the area is equal to 80x minus 2x squared, or if you prefer, you can put the x squared first and make it a negative 2x squared plus 80x. Either one of these is perfectly okay. So we have found a formula for the area of the garden. We've done that much. Next, we want to find the dimensions that would maximize the area. So I want to make this area as big as possible. Well, wait a minute. If I were to graph this, I'm not going to do it specifically, but I'm going to think about it at least. My a value, lowercase a value, the coefficient on x squared, is negative. That means this is a parabola that opens downward. If I want to find the maximum, I'm looking for that top point. That's the vertex. So I need to find my vertex. We need to use x is equal to negative b over 2 times lowercase a, which will be a negative 80 over 2 times negative 2. And negative 80 divided by negative 4 is a positive 20. If you do leave your area in this form, the 80x minus 2x squared, make sure you're still using the correct a and b values, because a, your lowercase a, is always the coefficient on x squared, and b is the coefficient on x. So just make sure you don't lose that. So we found the x value of the vertex, which is also the width. So we want the width of our garden to be 20 feet. We know that the length is 80 minus 2x. So 80 minus 2 times 20, that's 80 minus 40, which is 40. So we want our length to be 40 feet. Finally, we want to find the maximum area of the garden. We know that this happens when the width is 20 and the length is 40. So to find that total area, that's going to be 20 times 40, which is 800. So if we take 20 feet times 40 feet, we get 800 square feet. It's going to be the area of the garden, and these were the dimensions.